Welcome to AMTRAN, a third-generation, multi-terminal, conversational mode computer system. The appearance of third-generation computers, with running speeds 25 to 50 times faster than the second-generation computers which they replace, has resulted in acute shortages of the highly specialized programmers needed to utilize multi-million-dollar computer installations at peak efficiency. It is already abundantly clear that for scientific problems, programming costs will greatly exceed computer running costs. One solution may lie in making it possible for the scientist or engineer to converse with a computer in the natural language of mathematics, thereby increasing his effectiveness by combining the speed and power of a large computer with the accessibility and simplicity of a slide rule. These considerations have sparked the development of AMTRAN, a low-cost, automatic programming, remote terminal computer system. This is an experimental model of an AMTRAN terminal. From this keyboard, the scientist controls the computer to which the terminal is attached. The user has a specially equipped typewriter to provide a permanent copy of his programs and results, typing them out in their natural textbook format. This cathode ray storage scope gives printed displays of the user's instructions to the computer, as well as printed output data displays and graphical representations of solution curves. If he is not quite certain where to begin when confronted with this array of equipment, the scientist may push the General Instructions button. This will provide him with sufficient guidance to begin using the computer. A Special Instructions button is also available, which provides detailed instructions concerning each of the many buttons on the keyboard. One of the most useful of these operators is the solve key. This operator solves various standard types of differential equations with the aid of Runge-Kutta algorithms. The solve operator has been programmed in the conversational mode, in which the computer asks questions to which the user must respond. If the scientist ascertains that his equation is of the appropriate type, he communicates this fact to the computer, which then responds with further instructions. This leads to a true conversation between the man and the machine, in which nonlinear differential equations may be entered and solved within seconds. Almost immediately, the solution appears on the cathode ray scope face in the form of an automatically scaled curve. A Polaroid camera may be used to record such curves for permanent retention. Now suppose the scientist wants to write his own procedure for solving an equation. He simply presses those buttons needed for the letters, numbers, and operators and enters his own equation. Now, this system also finds immediate applications to space orbital problems. Here we consider a low-thrust space vehicle starting from a circular orbit and spiraling out around the Earth until it reaches escape velocity. Within the near future, it should be possible to provide virtually every technical person who needs them with snapshot simulations of the evolution of physical systems using low-cost terminals such as these. Three-dimensional figures can also be displayed. To generate a figure of revolution such as this, all that the user needs to tell the computer is the curve which he wishes to display and the angle at which he wishes to view it. The computer then generates the three-dimensional figure, automatically sizing it and filling it in as required. Families of curves can also be displayed in this manner and can be rotated as desired for better views of them. A key feature of the AMTRAN language is its emphasis upon automation of the programming and numerical analytical process. AMTRAN will ultimately accommodate a large class of routine classical and numerical analytical operations which are presently the province of the human mathematician. To achieve this goal, AMTRAN has been given an expandable instruction set. This feature permits the user to rapidly construct high-level logical, mathematical, and symbol manipulation operators from the keyboard, so that he can operate with larger building blocks than is possible with most other languages. Turning to future efforts in hardware, a stylus is presently under construction, which will permit the user to enter graphical data directly into the computer. The experimental AMTRAN terminal, which you have seen, will soon be replaced by a more advanced version as shown in this artist's conception. The effective cost of this more advanced terminal should run between $6,000 and $10,000, which makes it possible to think of placing such consoles at critical points throughout industrial, federal, or university installations. The AMTRAN system which you have seen is still only a year and a half old. What it will become in 5 years is difficult to say. But one fact seems certain, that conversational mode systems such as this cannot fail to exert a powerful influence on scientific and engineering computations throughout the coming decade.